Going. So this is we're just doing a review of paper 3. Okay, so I have with me, I think it's the 2019 or 2020 paper. I'll it will say in the description. But then essentially the trouble with this is it's an experiment, so I'm supposed to be actually carrying it out and then you seeing every step. But then as of now, we are not able to do that. So what I'll do instead, since most of you are really looking forward to the paper 3 questions for combined science, what I'll do instead is we'll just discuss some of the things that you should look out for, and also some of the principles that they test in the combined science paper 3 exam. Okay, so this question, the first question, question 1, it says you're required to determine the pH of 3 liquids. Okay, so you're told you're to determine the what, the pH. Yeah. Okay, so what does it mean exactly? So pH is a measure of the hydrogen ion concentration. So let me see if I can get a blank slate here. So pH, usually it's small letter p and then capital letter H. Okay, it's a measure of the hydrogen ion concentration. Okay, this is what it actually measures. So the concentration is normally given as this. But the way that we simplify it in combined science is that pH measures, so this is what you would write if you asked, the degree of acidity. Okay, so from acidic, acidity, or alkalinity of a solution. Okay, so these are called hydrogen ions. There's just a proton here. Okay, these hydrogen ions, they are the ones that are responsible for a solution being acidic. Okay, so if we have more of this, we'd have a more acidic solution. If we'd have less, we'd have a more basic solution. Okay, and then incidentally, we actually have what we call OH minus. They're the counterparts of H. So this one and this one, they combine to make water. Okay, so if you ionize water, you actually get this and this as well. So this one, they're called the hydroxide. So hydroxide ions, these are called the hydrogen ions. Okay, bear with me and then you'll be able to understand. So more of this, it means basic. Okay, and then less of this, it means acidic, more acidic. Okay, so you usually in a solution would have both these, they're present. If we have more of this than the other one, then the solution would be acidic. And if we have more of the hydroxide than the hydrogen ions, would have a solution that's more basic. Okay, so it's a little bit more complicated, but then these are the two generalizations. So when we are measuring the pH, it's a scale 0 to 410. Okay, this is the pH scale. So this scale is a mapping of hydrogen ion concentration. So this symbol here, if you put hydrogen and then you put these square brackets, you actually mean hydrogen ion concentration. That's what you mean here. Okay, so the hydrogen ion concentration, normally you would have, let's say, 1.2 by 10 to the power negative 5. This one is it would be in moles per dm cubed, or moles per liter. Okay, so if you're given this, it's really hard to tell if the solution is acidic or if it's alkaline, basic, and then also to what extent is it acidic, to what extent is it alkaline, okay, is it basic. So for example, if you want to compare it to, let's say, 6.0 by 10 to the power negative 4, then which one is more acidic, which one is more alkaline? These are really confusing numbers, okay? These are really confusing numbers. Standard notation is not very natural to us in terms of understanding. Okay, people, if you, that's why normally we use percentages. So I can tell you, hey, you scored 60% because it's easy on the tongue. Okay, it's also easy on the head as well. Okay, so we were going for something similar with this. We wanted to grade the pH values, the hydrogen ion concentration, the degree of acidity and alkalinity of solutions. We wanted to go for that, and we wanted to make it such that people can easily tell whether a solution is acidic or basic, and to what extent it is acidic or basic. Okay, so we made up a scale called the pH scale. So the pH scale is ranges. It ranges from 0 to 410. Okay, so this is really easy to understand. This is easier to understand than having to read hydrogen ion concentrations in this way. Okay, so if a solution is let me give you a range. So if a pH, let's say it's less than 3. Okay, so it's 1 to 3. So let's say it's less than 3. We say that the solution is a strong acid. Okay, so this is now easy to understand, because if this one has a pH of less than 3, then we would know directly. If you just tell me the pH of the solution is 2.6, I would know directly that that's a strong solution. That's a strongly acidic solution. Okay, so that's a strong acid. Solution is a strong acid. Okay, so if the pH it's greater than 3 but less than 7. Okay, so if the pH is greater than 3 but less than 7, we say it's a weak acid. This is important. Okay, just take note of it. And if a solution has pH equal to 7, we say this one is neutral. Okay, so if pH greater than 7 but less than 12, okay, we say this one it's a weak base. Okay, if the pH is greater than 12, we say this one it's a strong base. Okay, so this is the background. The way that we would read pH from 0 to 14, it's easy for us on the head and also on the tongue. So if, for example, if a solution is pH 4, then you'd know it's a weak acid. Why? Because for the range 3 to 7, those are weak acids. Okay, if a solution has pH 11, then you would know that it's a weak base, because 7 to 12, those are weak bases. Okay, so pH, it's a very convenient scale that we use. It's a very convenient scale. Instead of using hydrogen ion concentrations here, we would use the scale, and then the scale, it's freaking convenient. It's very convenient. Okay, so that's why we love it. And this is your sort of like the general range, and also the qualitative aspects of pH. So the quality. So if the pH is less than 3, would say it's strongly acidic. So the solution is a strong acid. So we measure that pH, and if we find it's less than 3, then it's a strong acid. If it's between 3 and 7, it's a weak acid. If it's 7, like distilled water, it's neutral. If it's a weak base, if it's from 7 to 12, okay. If it's greater than 12, it's a strong base. So strong base, again, it means we have more of those. Okay. Strong acid means we have more of those. not to take you too much into the weeds, but essentially, yeah, this is where I was just illustrating why hydrogen ion concentration can be hard to understand intuitively. Okay, so pH, it's actually equal to negative log of the hydrogen ion concentration. Okay, so we are not changing anything really. We are just taking the hydrogen ion concentration, which is hard to know whether a solution is strongly acidic, it's a weak acid, is it a strong base, is it a weak base. So this is the formula which would map all the values of hydrogen ion concentration to a point on this scale here from 0 to 410, such that it's freaking convenient for us. Okay, so we have several ways by which we can actually infer if a solution is acidic, or it's basic, and if it's a strong, or it's a weak acid, or a weak base. There are some ways that you can know. Okay, so usually those are the ways that they test for in your exam. Okay, so the here they will give you a universal indicator chart, okay, and a dropper, and then they also give you a universal indicator solution like this, which is really great. It's one of the ways that this is one of the ways that we can test for pH of a solution. So a universal indicator solution, it's a solution that's designed specifically to give as a proper color change, which we can map to a certain pH. Okay, just like what I was doing there with the pH of those solutions, to say, okay, this is strongly acidic, this is not strongly acidic, this is a weak base, all those things. We can also attach them to certain colors if we design a solution that gives a certain color that we can rely on. Okay, so the universal indicator solution, it's a solution that we use to measure the pH. So the way that we'd measure it is qualitatively. We would observe the color change, and then we would check whether the color change corresponds. So there is a chart, so universal indicator chart. The chart will be having. Let me show you the chart. So the chart is this one. It shows certain color changes here. So if you get this really deep red, then you get it's a pH which is equal to or less than 3. That means that it falls into the strongly acidic range. Okay, for greater than 10, you get this particular color here, and for 9 you get this. Okay, so you're given a chart. The chart that you're given might be different than this. Okay, this one is used by Words Science. Okay, I just got it online. So yeah, but then essentially you'll be having your own chart there, and what you're supposed to do is to do an experiment, observe the color, compare the color to the universal indicator chart that you have. If let's say you do you conduct your experiment, and then you find out that this is the color. So what it simply means is that it's a pH of 7. That's what it means. Okay, so let's go back to so here. What you'll be having is some things that you may want to look out for is that your universal indicator solution should not be contaminated. Obviously, none of the samples should be contaminated. These are 3 liquids, so these 3 liquids, you must not use the same apparatus for them. Okay, so if it's let's say you need a pipette, so there's something called a pipette. Okay, so this is you can use it for dropping or something else. Let me show you. So this is the pipette. Okay, so this bulbous head here, you can press it, and then what it does is that it creates some suction. So if you press here and hold, you can put this pipette here into a solution, and then you can release, and then the liquid will be sucked in. Okay, so you just need the specific liquid. Usually they tell you, let's say 2 millimeters, just measure 2 millimeters and then you're done. If you have any excess, it's not advisable to put back in the same solution that you'll be using. Okay, you put it somewhere else, and the assumption is that these pipettes, they're clean, so they're either really new, so these are really cheap, so they can be new, or they can be washed really clean and using distilled water. Okay, usually they prepare this for you in the lab already. So this is your one of your friends for this experiments. Okay, so you're given, at least for the universal indicator, you should use the same pipette. Okay, so don't mix up, use the same pipette for the universal indicator, such that it's not mixing with any solution there. So you'd have two test tubes. So test tubes, they're like this. Okay, so you'd have three test tubes rather, since you have three samples. You just measure. Let's say you're told to put 3 millimeters here, and then you separate them. And the pipettes, the little stuff that we're talking about. So where are the pipettes? So the pipettes are those ones. You should have separate pipettes for the separate test tubes. Okay, these solutions must not mix. If you mix them, then it becomes a problem for you. Okay, so each pipette for each test tube differently, and then you have another pipette for the iodine solution. So you have 3 4 different pipettes there. This idea is continuous in chemistry. Okay, that solutions must not mix unnecessarily. And the other idea that we talked about is that you shouldn't put back in the same solution, because you risk contamination. So whatever utensil that you're using, if you have excess, put it in some other solution. Don't put it back in the solution where you took the stuff from. Okay, so you have these three. You put your samples, and after you put your samples, you put your drops, 2 drops of universal solution. After you put 2 drops of universal solution, you shake, you shake, and then you shake well. No, not too rough or anything like that, but then you just shake gently, and then well, until you observe a color change. And then if the color change is sustained, now you take that color change, and then you compare it to your universal chart, and then you just map the color change to a specific pH. That's it. And then you'll be able to write on your, so you'll be able to write here. So color after adding universal solution, so you just write, and then the pH now, it will be based on the universal indicator chart. Everything that you're doing, you're taking it from the experiment. You're not taking anything from your head. Okay, then acid-base nature of liquid, you say the pH, and then if the pH is less than 7, then obviously you say it's an acid. Okay, if it's less than 3, just like what you talked about, it also goes a long way if you'd say it's a strong acid as well. That would give you some extra marks. But then if you're not sure, just say acidic or basic. Okay, for the 3 solutions here. If there's no color change, obviously it'd be neutral. So that's the original color that you would find for the universal indicator solution. So if there's no color change, then you say that it's neutral. Okay, so the color of the universal indicator solution is just observation. So they expect you to actually tell just by saying the universal indicator solution, put it in a test tube, just a few drops, you'll be able to tell what color is there, and then you just write. Most of the stuff, you're not taking anything outside. Okay, it just helps sometimes if you know. Here you're even told that this is a dropper. Okay, so this is a dropper. You're even told that you're given a dropper. This is the pipette that I was telling you about. So the pipette is to pipette out the universal indicator solution here, and then you drop it to the test tubes. Here the test tubes, they are prepared for you already. Okay, so you're good. But then if they are not prepared for you, just bear in mind that you're supposed to have separate droppers for the separate test tubes. Okay, and then you identify here. Let me give you one example, so I can have so I don't know what color to put, but then here I can say, okay, so the pH, let's say it indicates that the pH is 3. Okay, if it's 3, then I can say strong acid. Just that, it's done. This is the qualitative description. This is the quantitative description. Sometimes it's not 3, maybe it's 1 to 3, depending on what chart you're using and also what solution you're using. They will tell you the chart, you just have to compare the colors. This is really basic, okay? So this is what you have to do, and don't mix up anything. So is this for the uh, one of the precautions is the universal indicator solution. Okay, it can be, let's say, it can be temperature sensitive. It can be maybe 25 degrees Celsius. This is the standard ambience or temperature. Okay, the expected normal labs, they are usually around this temperature here. So you'll be able to do experiment well in those optimum conditions. And then as for the precautions, you use standard pH chart. So just like I told you, don't use anything else. Use the universal indicator chart that you're given. These are different. There are variations of the universal indicator charts out there, depending on what solution you're using. Okay, but then use the standard that you're given, and also depending on the accuracy. So, and then use a different dropper. Obviously, we talked about this. Don't use this dropper to take any of the 3 liquids out. You'll be contaminating the universal indicator solution. And then also, if you're going to drop the solution, so drop equal amounts, okay, of the universal indicator solution. Okay, don't drop excess, just drop equal amounts. Okay, it makes for good control for the experiment, so that you're not changing anything. Okay, so you drop equal amounts in the solution, and what you realize is that usually the test tubes, they'll be having equal amounts as well of whatever solutions will be there. Okay, and then you shake well before noting the color change as well. Those are some of the things that you have to look out for, and then look out for contamination of test tubes, because it's one air as well. If your test tubes are contaminated, then it's a problem. Yeah, so that's it. I know that this is not really thorough, so there are some things that you also have to figure out in the experiment. This is not really thorough. The limitation was that I could not do the experiment myself. Maybe in time I'll be able to, and then I'll actually show you like how it's done. But then essentially, if you just follow what I gave you, the background, sometimes it helps if you actually know what pH is, and also what the values mean, and also the base acid nature, what that means as well for the corresponding values or corresponding range of pH. It actually goes a long way. Okay, and yeah, that's it. And then know some of the basics, that you're not supposed to mix up any liquids unnecessarily. And then also you're supposed to use a different dropper for the 3 liquids in the test tubes, so that you don't have any contamination happening there. And for the universal indicator solution, obviously you'd use the dropper that you have. For our case, these solutions, they were prepared for us, so it was kind of easy for us to do that. And then everything else is just observation, and also thinking. There are some generalizations that you can make, so be able to make that maybe in a later video. But essentially, if you were to measure the pH, this would be the one of the ways that you do it. There's also the pH paper one. I think we'll cover it in a separate video. Another way to measure the pH, because they might not, this time they might not use the universal indicator solution. Maybe they'll use pH paper, and then it would be up to you to actually investigate as well in a different method, but somewhat similar. So you should know at least for this one, and then you should know the alternative ways. If they don't give you the alternative ways to if they don't give you one way, so for example, if here they don't ask you for pH paper, they might ask you in a different different question now, to say, okay, what other alternative would you have used to measure the pH? So you're supposed to know all the methods, even calculation method as well. It's more helpful for you to, it's very helpful for you to actually know the calculation of pH sometimes. And then yeah, that's it. So I think we've pretty much touched on everything that we needed to. We touched on the definition of pH, why the pH scale is necessary, why don't we just use the hydrogen ion concentration. So we explained that part, and then also what it is, uh, and then we explained the procedures, the universal indicator solution. We explained what exactly role it plays uh, in in detecting the pH. So we did that, and then we also discussed some precautions. So some precautions simply means uh, things that you need to do to avoid error. Okay, so here I even said you should drop equal amounts of the universal indicator solution, and also avoid also shake well before you note the color change. Okay, and then the other one, use the universal indicator chart, nothing else. Okay, so yeah, that's it, and we'll catch you in the next video. Thanks for watching. Yubo out.